Find the roots of the equation x cubed minus 7x plus 6 equals 0. We'll start this by applying the rational zeros test, which says that our possible rational zeros include factors of the last term divided by factors of the leading coefficient. So the numbers that go into 6 are 1, 2, 3, and 6, and all their negatives. The only numbers that goes into 1 is 1. And then we have all possible sign variants on this. So writing this list out, we've got 1, negative 1, 2 and negative 2, 3, negative 3, 6, and negative 6. We're just going to go through these in order, testing each one with synthetic division until we find one that works. So we're going to start out with x equals 1. That was our first possible rational zero. And then we'll do synthetic division to divide that out. So we're going to copy down the coefficients. We've got 1x cubed plus 0x squared minus 7x plus 6. Now remember, we start by taking this leading coefficient and just bringing it down. We then multiply these together, so 1 times 1 is 1, and then we add them. 0 plus 1 is 1. Multiply again. 1 times 1 is 1. If we add these up, we've got negative 6. Multiply again. 1 times negative 6 is negative 6. Add these together, we get a remainder of 0. Right, this last term is the remainder. Since we have a remainder of 0, that says that yes, x equals 1 is a 0. And once we've divided that out, these numbers right here give us the coefficients on the depressed polynomial. So we've got 1x squared plus 1x minus 6. We want to know where this is 0. So we're going to set this equal to 0. And because we have a quadratic, we'll hopefully be able to factor this. And if that doesn't work, then we'll try the quadratic formula. So in order to get x squared, this must have come from x times x. Now we're looking for two numbers that multiply to negative 6 and add up to positive 1. So positive 3, negative 2 will do that. Now we factored it, we'll split this into two separate equations, which gives us x plus 3 could be 0, or x minus 2 could be 0. We'll solve this first equation by subtracting 3 on both sides, which gives us x equals negative 3. Over here we'll add 2 to both sides of the equation, so we get x equals 2. So now we've found all three roots. We found x equals 1. Now we've just also found that x equals negative 3 and x equals 2 are also roots of the equation. So that makes our solution x equals 1, x equals negative 3, and x equals 2.